Hello, everyone, and thank you, Northern Ireland Dev Conference, for putting on such a great conference so far and giving us the opportunity to talk about one of our projects. My name's Sarah Byrne, and I'm the product manager at Flax and Teal.
I am Soltanagha Huseynov, software engineer intern for the Flax and Teal.
Flax and Teal is an open source focused software development company based in Belfast, specializing in web development for computational engineering, geospatial analysis, and data science. This paper will describe the intended research as well as the technical approaches used to develop translation functionality in web app software OurRagingPlanet. We will describe the intended research centered on student-driven development of the platform, promoting ICT learning, cultural understanding, critical thinking and tolerance in the students in Saudi Arabia and the UK. And we will evaluate the objectives, user research methodology and potential issues surrounding user testing during the COVID-19 pandemic. In fact, we will be able to discuss the current COVID-19 related barriers at length, as they have affected the proposed outcomes of this paper. From a technical standpoint, Soltanagha will discuss his experience of developing multi-language functionality for the existing platform. So in 2016, Flax and Teal developed an open source web app platform called OurRagingPlanet, which simulates natural disasters in a person's geographical context. For instance, a user could simulate a storm surge in Newry and follow the geographical and human effects of the surge on the affected area using the timeline function. To simulate natural disasters, OurRagingPlanet utilizes open data from sources such as Copernicus. The tool also harnesses open source geospatial data from OpenStreetMap and localized open data, such as OpenData.ni, to populate assets such as houses, landmarks, heritage sites, and street lamps. The educational tool allows users between the age of 11 to 16 to simulate natural disasters using existing models such as earthquakes, volcano eruptions, storm surges, and sandstorms in their locale or any other geographical location. With enabled timeline functionality, users are able to track the breadth of impact on the locality. In an educational setting, OurRagingPlanet spans a number of disciplines: geography, ICT, science, citizenship, and history and heritage, to name a few. We have partnered with Professor Patricia Marybelle Davies of Prince Mohammed bin Fahd University in the Kingdom of Saudi Arabia. The project is graciously funded by the First Futures Research Grant. Internationally focused from its conception, we are able to use OurRagingPlanet to increase learners' geographical understanding by illustrating the short and long-term effects of natural phenomena in the learner's local context. Professor Davies states that OurP Sandstorms is innovative in that it brings together several elements of the science and geography syllabuses that some students may find hard to relate to in a personal way without contextual local data. The project objectives are threefold. Firstly, to promote computer science learning through the use and development of the existing OurRagingPlanet platform. This also includes translation from the default English language to Arabic, left-to-right orientation, and sandstorm simulation creation. Secondly, to present learners with the ability to experience the impact of natural disasters such as sandstorms, earthquakes, and storm surges on their locale, as well as people living in different regions of the world from theirs. Thirdly, to assess how simulating sandstorms with OurRagingPlanet can teach cultural understanding between learners in KSA and the UK, critical thinking, resilience, and tolerance. OurP Sandstorms will focus on students in KSA and UK schools, beginning with Saudi Arabian students. The platform enables immersion into dynamic, naturally occurring disasters and events such as volcano eruptions and dust storms. During phase 1, sandstorm simulation functionality will be enabled within the platform. Saudi Arabia is 95% desert, and sandstorms are an annual occurrence. Therefore, the majority of learners in the Arabian Peninsula will have already experienced a sandstorm or know a relative who has witnessed the dust storms themselves. As well as simulating known phenomena to their locale, learners can simulate events in different countries, visualizing the effects of natural disasters from the comfort of the classroom or their kitchen table. This is particularly interesting in the UK context, as simulation can encourage empathy and cultural understanding amongst participating learners. For educators, this is particularly attractive as it adheres to the fourth and fifth principles of the 5 British values that teachers must incorporate into their teaching in England, in that schemes of work in each subject promote mutual respect and tolerance of those of other faiths. In the Saudi Arabian context, the use of the software will be teamed with specially designed resources, as well as those from the initiative www.tolerance.org to promote the teaching of tolerance in the classroom internationally. The platform contains timeline functionality, allowing users to follow the life cycle of the disaster and develop their understanding of the need for resilience and disaster management processes. Indeed, it also deepens their understanding of the scale of the impact of such disasters. Creating empathy with those affected by natural disasters outside of their cultural context. In addition, students learn the physical basis and limitations of their natural events. OurRagingPlanet can also be customized by learners. For example, students can customize and create their own simulation logic in Python and virtual or augmented reality, in addition to Raspberry Pi projects. Wishfully conceived at the start of the UK and KSA lockdowns, the project timeline had initially stated that we would conduct classroom-based user testing in predominantly Arab-speaking KSA schools during phase 1 of the project. However, as of late August, the Saudi Arabian government announced the extension of distance learning indefinitely in the wake of the pandemic. In light of this announcement, the project has pivoted to remote learning objectives and data collection if necessary. Indeed, it was hoped that during this paper, I would be able to discuss the outcomes of user testing in the KSA education system. However, due to the red tape surrounding educational research in KSA, as well as the current global health crisis, we are still awaiting confirmation that we can begin testing. Teachers will be provided training on both the platform, as well as provided additional teaching resources to help contextualize the use of natural disaster simulation within the scheme of work. The interface will be tailored to simplify use. Teachers can easily add relevant simulations for learners to run on their chosen locale. This quick setup is well suited to distance learning, allowing teachers to maximize face time with students rather than preparation. In phase 1, we hope to use the OurRaging platform to assess how learners understand the impact of natural disasters, analyse situations and plan how to protect vulnerable citizens during such events, and develop resilience and empathy for those who suffer from those events. In this pilot study, from an educational perspective, qualitative data will be collected from teachers via questionnaire to assess student engagement. Learners will also be given graded and skilled assignments centered on building tolerance through the use of the OurRagingPlanet software. From a product perspective, our initial user feedback will be secondhand from teacher and teaching assistant questionnaires. These questionnaires will focus on accessibility and the challenges faced by learners when using the software. This will be especially important in relation to mixed ability classes and differentiated activities.
The OurRagingPlanet platform uses BFF, which means the backend for the frontend, a single-page application. In the backend, we are using the Laravel and Wheel for the admin panel, allowing some of the functionality to compile in the backend, then render on the frontend component. Laravel application provide a better performance than the applications built with other framework to caching system. The file cache driver stores item in the file system alongside the dockerizing the Redis cache for the dynamic values along the for fast application development. It provides a simple and efficient authentication system and access controls out of the box, allowing you to restrict the access of the unauthorized users to certain resources. Additionally, it provides application security as the framework's code base is protected from the threats such as the SQL injection or the cross-site request for it, protecting loss of the user data. This framework has a built-in elegant ORM system which allows you to work with the different database utilizing the implementation of the active record pattern. With Lucan ORM, you can work with the chosen database without having to write some complex SQL query. Indeed, Laravel supports MVC architectural design as we are able to separate the user interface and business logic. It also supports the blade templating engine, which allows native PHP code to be used. This is deployed on the Kubernetes cluster together with the disaster simulation serverless function using the OpenFaaS. Twill is a Laravel-based framework which has helped us to build our custom CMS, which means the content management system that is user-friendly, powerful, and dynamic. This framework has pre-built features and associated library of the Vue.js UI components, allowing the developer to focus on the special needs of their application. The front-end development with the Vue.js backend and the front-end connected with Nginx service, which Vue.js allow you to split your application or page into logical units that can be used reusable components. Each of those components can contain HTML, CSS, and JavaScript code, which is inherent only to this component and is responsible for its performance. This framework is a solid JavaScript library with its own ecosystem that allows you to easily scale an application being developed. Vue.js is defined as the view model layer of MVVM template. It connects the model and view, two-way data binding. Current vDOM change and format output are abstracted into directives and filters. Using vDOM completely separates possibility DOM manipulation with the functional layer. Now the functions code works declaratively by composing vnodes, which makes it easier to maintain and add new functionality. The first step in the translation process was the separate Weblate and Git repository for the integration. A Weblate is the web-based translation tool that supports Git integration and number of the file formats. It offers all the features for professional translation work and also gives version control support. There are several ways to integration between the Weblate and Git, but the most suitable for us was using the translation repository like a submodule. That's why before start the configuration for Weblate, we have prepared a Git repository which will synchronize the translations. For accessibility, we use the SSH key, which also generated by Weblate, and append Weblate user to our project with maintainer permission. This kind of the approach allows to us avoid the merge conflict. If we will integrate our backend and frontend repository, we would have to add this user to each of them and configure the SSH key. A Weblate server can host many projects, each of them which can have separate translatable components. In our case, we have the single ORP project in our Weblate instance, which front-end and back-end components. However, inherent problem with using this structure is that translation will take place separately in each of the components, which means translator need to be each word translate twice, in once in the backend and once in the front end. Therefore, one of the benefits using the submodule was that it allowed to us use the ORP project as well as the one ORP localization component. The second step in the process was to build an infrastructure for the localization support. We decided to use GNR getText format, which has many advantages when using in the website. For example, it allows to build bilingual translation as well as the plurals. Therefore, we have to append plugins for Laravel and Vue as a frontend, neither of the support .po file extension. In the backend, we used Laravel getText node module, and for the frontend, we used Vue getText. Laravel getText doesn't have the functionality to extract text from the blade templates, which is the why we write our own console command, which is PHP scanner, blade compiler, and PO generator support. The PHP scanner module can find the tags underscore, double underscore, and underscore I, as mentioned in the templates. Then PO generates builds .po files for translation. As Vue getText doesn't support extracting strings from a project, we use a EasyGetText framework in the frontend. EasyGetText can install general node modules and has commands which extract from Vue component and compile it to JSON file. This JSON file used for translation is defined in the project as a main.js. Thirdly, we have to merge the two-word and annotation lists and .po files to one of file for the weblet and create continuous integration. Merge operation can be done with the msg-cat command. However, in the folder level, we must define the sum location for both. The most appropriate place for the folder in the submodule, as it allows to us use easily access and synchronize the .po files. In the Arabic, not only text separates from the right to left, but the entire page layout. For example, images that indicate direction should be flipped. The dir attribute tells the browser the direction of the text in an element. To set global direction of the page, you must set the dir attribute for the entire page. The key attribute values, one of the LTR, which is the left to right writing. For example, we can say English and Swedish. And RTL is the right to left writing, which is the Arabic, Hebrew, Persian. Auto tag means the use for dynamic content. The browser chooses the direction itself. The Unicode bidirectional algorithm is used to process elements and determine the direction. But the dir attribute might not be enough for the reflect the entire UI to RTL. There are too many asymmetric CSS properties to watch out for when designing a website that supports both LTR and RTL. For example, we can say margin left commands with some property with pixel text aligned to right, and it means like here most of the page will be flipped to right, and also the Arabic letter in the ligature. Most, if not all of characters in the word are related to each other. For this reason, no inter-character spacing should be used in Arabic. We would not need to tear apart symbols breaking natural ligature. Additionally, some Arabic letters are higher in the line than line the English script. For this reason, you may need to increase the line height for the Arabic. This is the current focus on my development work.
In developing the sandstorm simulation and translation functionality within the existing open source OurRagingPlanet software, we are able to use the platform to spearhead the teaching of cultural understanding and tolerance through natural disaster simulation. We have achieved language functionality through the use of Weblate as well as submodule, where we are able to store and integrate the .pot files. However, the most challenging aspect of developing Arabic functionality is in fact the right to left orientation of the script, as well as the images and navigation. I hope that this has given you a detailed overview of the project so far, though delayed by the COVID-19 pandemic. If you've enjoyed this talk, please follow us on Twitter and LinkedIn for more updates on how the project is progressing and information on how to participate in International Tolerance Day on the 16th of November. Thank you all for your time, and I hope you enjoy the rest of the conference. Thanks a lot.
Thank you.